Hello everyone and welcome to this IFST webinar that's been organised by the IFST Innovation Special Interest Group. My name is Tom Hollins. I'm the Innovation Technical Director of Rainer Foods and also a Fellow of the IFST, and it's my pleasure to chair this webinar today for you. Today's session is entitled, "Can We Bake in Space, Man?" This is a truly inspirational story about a startup looking to try and address the scientific and technical challenges of producing fresh food in space. In this case, bread. Next slide, please. This webinar is being recorded and will be uploaded to the IFST website at the end of the session. Please feel free to make comments and ask questions throughout the webinar using the Q&A button, which you will find at the bottom of your screen. You can also upvote people's questions by clicking the like button next to their question. There will be a Q&A session at the end of the presentation where we will try and respond to as many of your questions as possible. Our speakers today are Sebastian Marcu, who is MD of Design and Data, and Neil Jasinski, MD of Applied Rocket Technology. If you want to know more information about our speakers and their biography, then please do visit the IFST website. So without further ado, I will hand over to both our speakers. I hope you enjoyed today's session.
All right. Yeah, thank you very much, Tom, for the kind introduction and for the invitation to tell you a bit about the story behind Bake in Space and the question whether we can bake in space. It has been quite a journey that myself and Neil, we undertook starting back in 2016 when we proposed this idea for the mission, for the astronaut mission of Alexander Gerst, German astronaut, who we felt would really benefit from fresh bread in space. Yeah, this is the kind of the back story of how everything happened and how everything basically evolved from that. So next slide, Neil. Yes, so humans have always been fascinated about the cosmos and the stars looking out from Earth and documenting them throughout history, throughout the ages. Cave paintings or documenting basically how they were moving about. And there's always been this fascination, what is out there in space. But interestingly enough, next slide, astronauts, on the other hand, we tend to gaze back towards Earth. And it has a lot to do with the rather alien environment that humans have to live with in space. So it's not really a comfortable environment. And so this looking back at space is a piece of comfort in their daily lives and their operations, and which is tricky. Next slide. Because if you imagine one day that humanity will probably fly out even deeper into the cosmos, and the gaze back at Earth is going to be a bit harder. And so what is really connecting us with Earth is trying to create a kind of a life that reminds us of our home planet. And what you see here is basically what Earth would look like viewed from Saturn. This is actually a picture taken by the Cassini-Huygens mission back in 2004. Earth is pretty much like a small blue dot in the depth of the cosmos, and it's really imagine on top of that the delay of voice communication or communication of any kind with Earth, which will probably see a delay of an hour, a couple of hours before any relay of information comes back to you, which makes it even harder. Next slide. So one aspect to make life better in space, and this is something that has kind of inspired us, is the thought that how can we create a better quality of life in space? And something what you see here is a kind of a glimpse of a nice breakfast table. Should be what you should be experiencing in space when you look back at Earth, even if it's just a tiny blue dot. But the reality, next slide, looks more like this. And there's nothing really enticing about this kind of breakfast. It's dehydrated foods, it's prepackaged, and it's almost a lot more clinical in that sense, trying to create a breakfast in space and enjoy kind of the quality of life that we might know from Earth. Neil, I think it's your turn.
Yeah. So what actually is astronaut food? And if you are interested in spaceflight, sooner or later you will come by Jules Verne and some of his books. And just 100 years before they launched the first man to the moon, he wrote the book A Journey Around the Moon, where he described how you have to do it with the state-of-the-art technology of his time. And also, he described a little bit about the food supply the travelers took with them. And it was more like what they used in that time for going on a long trip with a boat. So it was preserved food. And of course, this type of food you could use for astronauts, but the technology we use around them is slightly different to what he described in his book. And the roots of astronaut foods is nearly or mostly based on food they developed for the first spy pilots. So in 1955, Lockheed Martin built the U-2 plane that was able to fly 24-kilometer high. Why so high? The idea was to be out of the range of any air defense system, and going up was a solution. And if you go above 12 kilometer and you have a sudden drop in pressure of the cabin, then you need a pressure suit on to survive. At 12 kilometer, pure oxygen is just enough oxygen to survive. If you go higher, you will just suffocate. So the poor pilots, more or less, had to wear the spacesuit all the time, or the pressure suit all the time, with a closed helmet. And this mission could take up to 12 hours. And in 12 hours, sooner or later, you want to eat and drink something. So one requirement that came in was that you have to be able to eat it through a tiny porthole of your helmet, as we can see it here now with a modern version of this pressure suit. So everything what they eat and drink has to fit to this tiny hole. And this idea of the porthole in the helmet went up till Apollo era with the Apollo spacesuit, as we can see it here. But also this suit had some built-in food bars and also a drink supply. And if you are trapped in a suit where you cannot escape for 12 hours, also what you want to avoid are toilet breaks, because you cannot just step out and go to toilet. You have to sit in the suit for the whole 12 hours. So another point that comes in is low fiber content, that the need to go to toilet is less urgent. And if you go with these requirements, consumable via a tiny tube, low on fibers, and shelf lifetime at least long enough for the mission, we have something similar today, what you know from healthcare. If old people or sick people cannot eat anymore, then there is a drink that contains all the nutrients you need to survive. But yeah, you have to eat it through a straw, and you get, I think, 3 or 4 different flavors. And on Earth, not a big problem, but if it comes to space flight and you want to go to the moon, the food also has to be lightweight. And here, astronaut food technology, you can say, split up in 2 different paths. One is a Russian path and one is a path the Americans went. What you can see here are the 2 spacecrafts used for the Apollo-Soyuz test program. They had the idea that even they were in a Cold War scenario, that space travelers have to be able to rescue each other. So they're tested. Is an American spaceship able to dock to a Russian spaceship? So these are the two spacecraft. Every photo was taken from the other one. And on the right side, we can see the Russian spacecraft that has solar cells as a power supply for electricity. And on the left, we see Apollo. There is no solar cells visible. So what the Americans did to save weight, they came to the idea to use rocket fuel to generate electricity. And during this process, they used fuel cells for hydrogen and oxygen. You get quite a lot of exhaust water from this process. And a part of this water was used to rehydrate dehydrated food. So the food only contains the fiber content, and the water was later added to it. And if you know how much you eat per day and how much you drink, it's quite a lot. If you send 3 people to the moon, what piles up of weight of water. What also is interesting, and that's the last topic where I go this way, Russian spaceships already had a toilet on board, and the Americans still had just a plastic bag. Maybe because of the low fiber content of the spy plane food. So here we can see some examples from the early beginning of American spaceflight, what this dehydrated food looks like. You see peas on the left side, and the 2 other ones are powder for drinks. And what you did, the label told you how much water you have to put in it. On the top right corner, you can see a vent hole where you can add your water. Then you close it and let it rehydrate for, let's say, 15 minutes. And if it's food like peas, you can also start kneading a little bit to get the water concentration equally everywhere. Yeah, and then you open it and you start eating it or drinking it. And as you can see, this not really looks delicious. No? So maybe, then when America continues the program to go to the moon, they had one project called Gemini, where 2 people went to space for long time duration missions, up to 14 days. And maybe it was one of these pictures where John Young, the guy in front, thought maybe it is a good idea to sneak in a corned beef sandwich. So what he did, he hides the sandwich during lunch in his suit, and then once in orbit, he offered it to Gus Grissom. And on the right, you can see the dialogue that happened. But what happened is the sandwich started crumbling, and the stuff was flying around everywhere, and they quite fast figured out it was not safe to eat it, so they put it back in a bag. Yeah, it was the first sandwich, and it was also the last one because of the crumbs. So since then till today, food didn't change a lot. This safety requirement that is not crumbing lead to food that is quite sticky, like a paste. You can see it here. That is a so-called space hamburger also. Everything sticks together and it is not flying away. Luckily, on the ISS, they are now able to make plants growing in a tiny greenhouse. And 2014, they got the permission to eat the first leaf they harvest in space. And you can see it here on the right, quite happy people eating one leaf. But you can question yourself, is this really quality of life if you want to go for a longer mission and deeper into space?
Yeah, so, and it's exactly this question about quality of life, which has made us think about improving the quality of life. And especially if you think about the future plans of NASA and the other space agencies, first to return to the moon, which maybe is a bit easier to achieve than going further out into to Mars, because on the moon side, you can still resupply a moon base rather quickly. But if you wanted to feed a crew of maybe 5 people flying to Mars in a spacecraft, and still think about the consideration of weight, do we take all the food with us in one huge spaceship? Do we create little islands on the way of where you can refuel your food? Or is everything just created with the same resources on the spacecraft? And it's these are all tough engineering questions, and each one has, of course, its benefits, but also there's a lot of there's pros and cons to which way to go about it. I mean, generally, you can think that a typical Mars mission will probably take about 2.5 years. That includes a 1-year stay on Mars and the return back to Earth. Next slide. So our response to improve the quality of life was actually quite simple: bread. Bread had many connotations for us because next slide. Bread essentially has there's an emotional aspect with bread that ties us kind of to memories of childhood memories of eating bread, but also there's cultural connotations with bread being synonymous with quality of life, whether it's dough for money or the breadwinner that sustains the quality of life in a household. In German, we talk about the bread and butter business, the Brot- und Buttergeschäft. But in French, there's also the word copain, which comes from Latin, which means companis, so with bread. So essentially, if you look historically and culturally, it seems that bread is really synonymous with friendship, quality of life. It has really a lot of positive aspects, which made us think that, next slide, that essentially bread could be a stepping stone for going further out into space and advancing exploration of humans in space. Next slide. And what we had done is basically we had envisaged as part of the startup Bake in Space to figure out how do we get to bake a fresh bread roll in space. And we split it up into 5 phases, from growing the raw ingredients, to harvesting, to grinding it down to flour, to kneading that into dough, and then baking that. And we had essentially wanted to start at the end of that of this value chain, or this growth chain. And the initial experiment was a baking experiment, so that we could understand how do we achieve baking in space, so that we know what type of ingredients we need to then bake at the right temperature and the right method in space. And so our phase 1 is really at the end here, the baking part, before we wanted to embark onto the other phases, and each one essentially being another experiment, another piece of hardware that would be sent to the space station, so that we essentially could recreate that whole production cycle from grain to the final bread product. Next. So the idea basically came about with the announcement of Alexander Gerst. He was being announced to fly back to space in 2016. It was his second mission to space. And Alexander Gerst was already a very much appreciated public figure in Germany, especially, but also across Europe. And his mission was to take place in 2018. So when we had started the project Bake in Space, we had essentially over a year to when we really started get going, it's over a year to get everything in place, so that we could get a piece of hardware up into space. and enable Alexander Gerst to bake fresh bread in outer space. All right. So anyway, we proposed the idea to the German Aerospace Center.
No. Okay.
DLR, and they were and we pitched the idea basically to them, and they were quite excited about the potential of this mission. The main thing to note here is that DLR, since it was a German astronaut, DLR, the German Aerospace Center, was essentially providing the experiments for the space mission, together with publicly funded experiments from universities, and our mission was basically an add-on to this list of experiments, being a completely commercial experiments that needed to be basically self-funded entirely. So we were not receiving any grants from public money to enable this. So our goal was to try and bring together basically commercial entities that would be interested in partnering and making or enabling this mission, both from the space industry, but also from other industries that could see a benefit in terms of this mission for their own advertising, maybe, or as a means to drive innovation within their respective companies. And so we had a chance to bring on Miele, which is a oven manufacturer or households manufacturer in Germany, quite well-known one that stands for quality. And I mean, here in Germany, we jokingly, all the washing machines that are Miele, they last about 30 to 40 years. But they're also known for their ovens, and we managed to bring them on board as a partner together with OHB, which is a well-known space company in Germany, which was also the entity that was responsible for the rack where our experiment would be held on the space station. And as another partner, we had TTZ Bremerhaven, which is a research institute for food research, that was interested to join our project and help us develop really the recipe for crumb-free bread in space. So Miele was the oven side, the hardware side. OHB was the integrator of the hardware and making it space safe, and TTZ Bremerhaven as the entity that would create the fresh produce for space. And DLR and ESA essentially both were involved in this ESA mission. DLR would provide the experiments and enable really, or pave the way forward for us to bring this piece of hardware to space. And ESA that would essentially fund the trip to space. And there were many avenues open. So we, depending on when we could have finished the hardware, we could have flown on a SpaceX mission or on another spacecraft, which was flying experiments and goods to the International Space Station. The involvement of ESA essentially was also making sure that whatever we were producing was safe for use in space. Yeah, next slide. Okay, there was one point on the previous one. Yeah. Actually, one thing that was important here is also the involvement of NASA, because our project was food related. And as we were advancing the project, we realized how many steps, I mean, let's say the space industry has developed processes and mechanisms since the Apollo age, how to bring or how to develop hardware for space and make it safe, and how to make it space-proof and ensure the safety of the astronauts. And pretty much a lot of these processes have not been changed, so they're still the same. And what was interesting with our project is that we were a completely commercial project, which then was kind of revolutionizing as a first entirely commercial self-funded project, which was basically disrupting these processes. And there was really no set of processes established yet, even though the member states of the European Space Agency had already decided that commercial projects need to happen and they must happen. And so in that sense, we were probably guinea pigs with our project to kind of break up these kind of dusted processes. But one thing that we really needed to also decide is if we wanted the astronaut to try the food in space, which would have been a great feedback from the astronauts to see how this fresh bread would taste in space. But the process to get this approved required medical questionnaires to be filled in and prepared with a whole set of processes to enable that, which made it really, really complex for us to get the astronauts to even try a crumb of fresh bread in space. So and so we had to, as time went on, we basically were stripping the project down to really the bare necessities because we didn't have much time to get this hardware off the ground. Yeah, it's your turn, Neil.
Okay. Since it was a part of GERST missions, European, our location on the space station would be in the European module Columbus. And here on the right side, we can see a cutaway drawing of Columbus module. And you can see that the side walls were covered with racks filled with scientific experiments. And if you would be able to go into this module, you would see something like on the left picture. So this is already some months or years old, this picture, but you can see it's quite heavy in use. And these racks on the right side, the direct first one, the European drawer rack, would be our location for the experiment. And you can see this rack system has drawers in it. The whole system based on 19-inch rack design, we also know from IT department. And one of these blocks is the space we have to fit our oven into it. So luckily, one of these drawers they had as a mock-up standing at OHB in Bremen. And here you can see in the bottom left corner in one of these modules our prototype oven. So it fits nicely in. So our idea was, technically no problem. So let's do it, build it and fly it. Huh? But then all the safety regulations for space hardware kicks in. And the most obvious one, we already know, no crumbs. This is then something that the dough recipe has to solve. And if you see this nice bread on the right side, all different types, most of them based on yeast to produce the fluffiness inside. And yeast is something that is alive. And NASA was concerned that some of these yeast creatures will leave the oven and start a new life behind the rack system and slowly contaminating the space station. And this could cause problems. Another idea for that, to not use yeast we bring to the space station, we just use what is already there on the space station. So another type of dough is based on sourdough. That is something you set up the day before, and whatever flies in the air will sooner or later land on this dough and start creating new cultures. And this then will create later on the fluffiness of the bread. This sourdough idea made it up to the Maurer mission to make space-based yogurt. I don't know yet exactly what happens with the yogurt. We have to recheck it. But also if you make bread at home, or in a bigger scale in a bakery, you always start with flour, and flour is a quite dusty stuff. Every now and then also mills where they make flour explode because of dust explosions. So they also don't want to have dust in space. And also what big difference is to Earth is without any gravity, dust can stay quite long in air and can inhaled by the astronauts, and that can cause a health risk for them. So better not make anything that can escape the oven. Here we can see gas inside of this module. This is not our oven, this is just something else, but it shows quite easily how the working situation is there in Columbus. If you bake something in your oven at home in your kitchen and you open the door to get stuff in or out, you feel all the hot air coming out and directly escaping to the ceiling of the kitchen. And then it's safe for you to stand in front of the oven. But without gravity, this hot bubble of air just stays in front of the oven, and it only slowly gets moved away by the air conditioning system. And this is a safety hazard, because if the air has 200, 250 degrees Celsius and the astronaut pass it, it can burn the skin of the astronaut. So one requirement was that the oven is only be able to open when it's cold inside, or cold enough, below 50 degrees, and also make baking temperatures as low as possible, that there will no smoke generated during baking. If you want to have a nice dark brown crust, you reach quite high baking temperatures that can trigger the fire alarm system of the space station. So before we decided to only do the final step with baking, we had the idea to really create dough on site. And one idea was to just make it in a bag. So here I use a Ziploc bag, put all the ingredients in and start kneading. And at the end, I had a more or less nice dough. And astronaut time is quite precious in space. So you cannot tell him, please knead this for 1 hour and then you can have breakfast. So the idea was to create a kneading machine. And for that, we designed a plastic bag where only water has to be added. And then later on, it will be put into the kneading device for making the dough. Theoretically, you can also bake inside of a plastic bag that will look like this. It's a little bit unsharp, but as you can see, there's not really nice brown crust on it with a lot of flavor, and it more looked like a sponge and also tasted like a sponge. So we decided to go with pre-baked bread rolls. Pre-baked also has the advantage that they are sterilized during baking. So we don't contaminate the space station with anything that is still alive. And yeah, it's just a matter of measuring the size of a normal German bread roll and then see how big the oven has to be. So on the left is one concept drawing on how to hold it in 0G, because it will not lying on the tray. On the right side, we see the look into the prototype oven just with the normal tray during baking. Just for fun, I also tried to make croissants in it. Of course, croissants are the worst case scenario when it comes to crumbling. But as you can see, the oven itself was also able to make nice croissants. It will take a little bit longer than on Earth, but yeah, you see it's growing and getting nice brown. The problem, or the reason why it takes so long, is the low amount of power input we were able to get from the rack system. Standard power supply is only 28 volt direct current and with 8 ampere maximum. So that is 224 watt, what is like 10 times less what a normal oven at home has. And still the oven has to be able to make bread with that. Then there was a regulation of no peak load in terms of radiation, so opening it and release hot air bubbles. but also the requirement for heating up and cooling down. That is the part where it consumes the most amount of energy. That can't be so high. So we were really limited to this small amount of power input, and that makes the process quite slow. So heating up takes time and cooling down takes time. And normally you want to have a preheated oven and then you put in your fresh dough to get a nice crust. So what adds on to the complexity was, beside heat treatment, also moisture treatment. If you heat up over a longer period, your bread can start being dry already before it's done. And when you cool it down, all the trapped humidity coming out of the dough will go back to the bread and will make it soft again, or even like a wet sponge. And this is also something you don't want to eat, really. So we went to our to TTZ to develop the process parameters and also to develop the dough recipe. And what you can see here is on the left side their prototype oven with temperature and moisture controlling. And on the window, you can see how much of water already condensed during heat up and cooling down. And on the right side, you can see the prototype bread rolls. I was never able to eat one. That day I was not on site, but all my colleagues told me it really tastes nice. And what the most important thing is, this is really not crumbling at all. So that was quite innovative, and for that we also got some awards. But that's Sebastian's part.
Yeah. So so the project was well received. We pitched it at various startup competitions. Also because there was an aspect of education that we wanted to do with the project, where we would do hold kind of live baking situations with the astronaut in space, and teach children about the science of baking in outer space. And so we pitched the idea at various startup competitions. We had won some prizes and got commended at other occasions, like the UK Space Conference and the Inner Space Masters. And the other aspect, which was quite exciting, next slide, is really the media attention that this project caused. It's something that we didn't totally expect initially. So there was an article that got published in mid-2017 with the New Scientist. And within a week after the press release came out, we had over 200 citations of articles and online media around the world. It was really quite fascinating to see in all these languages people talking about Bake in Space. And then the highlight of that week for us was actually making it to the Jimmy Kimmel show, who had his own take on Bake in Space and the project. And I want to share this video with you from that.
The next great space race is on the way. A team of German scientists is working on a project called Bake in Space. Their plan is to attempt to bake bread in outer space. They're hoping to do it sometime next year. They say their goal is to address the, quote, scientific and technical challenges related to the production of fresh bread in space. Apparently, it's hard to bake bread in space, which, I'll be honest, I thought baking in space was a euphemism for smoking weed on the roof. I didn't know they were doing any of that. It's an interesting goal, and not only has the idea of baking bread in space inspired the scientific community, it also got creative juices flowing here in Hollywood and is breathing some much-needed life into the space action genre.
The mission's primary goal has been achieved. We're looking at the first proof of bread beyond Earth. It's beautiful.
We've lost all all communication.
That's perfect.
It's armor. Guillermo, did you understand what was going on there?
Yeah, I did.
What was going on there?
The bread.
You can
The
still
next
do it.
space race is on the way.
Okay.
Yeah. So so in the end, we had really achieved something quite amazing within the year, since we had basically pitched the whole project to. We pitched the whole project to DLR, and let's say one of the really tough ones was that we were very much focused on trying to meet this timeline for the mission. So we really put everything, all our efforts, in trying to meet this mission, which probably took away some of the opportunities that we just didn't think about at the time. And so the idea we initiated in 2016. It took some time to get the company up and running. 2017, we had Bacon Space registered as a company, and then we were put together a team which included OHB as the space integrator. And when we started putting the numbers together to try and meet this mission, including, let's say, the whole process of trying to produce space hardware in that amount of time, with the processes that were still the old processes, so we weren't allowed to use off-the-shelf products, but each screw essentially had to be space approved. It drove up the costs to such a high degree that it was almost impossible to get anybody interested in sponsoring this, especially from the food industry, which was really a shame. And the cost for the production of the space hardware was over €1 million, which was just an astronomical figure for one piece of oven hardware to go to space. And on top of that, we had various other problems related to getting the hardware certified, especially without government funding. And still our focus was trying to meet the mission of Alexander Gerst. And the other thing that we needed to try or that we wanted to achieve, is to try and get this piece of hardware to his mission in time, which meant that there were only, I think there were 3 launch opportunities on different vehicles, including SpaceX, Soyuz, and an orbital flight, and all of these were making it really hard, because each one had their own specifications, because we had to produce the hardware in Germany, we had to get it approved for customs, send it to the US. In the US, space hardware is considered also defense hardware, so there's a whole set of processes involved there until the moment that it's going to sit on a rocket and go up to the space station. There's so many steps to be taken, so many complex steps, which made it really almost impossible to really make it work within a year. And then on top of that, we had a bit of internal opposition by the astronaut image, that were not too happy with us being a startup and the use of astronauts for advertising. And again, I mean, there was absolutely no experience with this kind of commercial project. So essentially, we had stone being thrown in our way that I think today it would be much easier. I think we were probably much too early with the project, what we were trying to achieve at the time. Next slide. What is interesting, though, is that Bacon Space as a project, though, inspired other projects to take off. And this is something where I have to say, I mean, we in Europe, we're very slow in getting things done. There was some people in the US that we were in touch with quite early on, but we couldn't agree on common terms. And they essentially started their own baking project and got a top sponsor involved. Hilton, with their DoubleTree cookie, which is one of, let's say, the assets that you get if you stay at the DoubleTree Hilton Hotel. You get a free chocolate cookie laid down on your bed. And for them, it was a great advertising experience because it didn't cost as much to produce the hardware in the States. They didn't have many of the limitations that we had because they could use off-the-shelf hardware. So the hardware production costs were a lot lower. And essentially what happened is they managed to fly a piece of hardware, which if you see now our prototype, it looks very similar. They managed to basically fly a cookie up there, bake it in space. And guess what? The left astronaut here is an Italian European astronaut. And what is he doing? He's advertising for DoubleTree Hilton cookies. So essentially all the things that didn't work out for us, somehow they worked out for the competition. And yeah, it's a shame, but it's still fascinating to see that after all, there would have been ways to circumvent the obstacles. Next slide. Another project that got inspired was one of the food companies that we were in touch with also quite early on, Puratos. And there was a strong interest there to get involved in the mission. But one of the aspects there, we didn't manage to connect on common terms because our focus was trying to get the money together to fund the space hardware and fly the mission to space. But Puratos managed to create their own project and find local partners in Belgium and receive a Belgium research grant for this project. Basically researching bread production on Mars and basically looking at let's say all the ingredients from a perspective of let's say all the chemical composition of the ingredients, and they managed to receive funding of 6 million euros to conduct this research project. And if we had the time and if we had the different focus, I guess we would have been part of this research project with our project. But at the time we were, I would say, too blind to even think in that direction because we just wanted to achieve our mission and fly a piece of hardware for the astronaut to bake bread in space. Next. Yeah, overall, what I wanted to say here in conclusion is basically what the project shows and what I've seen now on several occasions is that space really offers a great opportunity to conduct open innovation for companies. And here on the left, you have kind of the typical funnel of internal ideas that then reach market potential. But what is happening with open innovation is that we are linking external collaborators and finding alternative markets for projects. And I think what I've seen with our project, the collaboration that we had with various companies that are non-space entities like Miele, and some of the food production companies that we've been in touch with that were very inspired by the potential of collaboration in this field. And I've seen it with other companies, like the food production company that is producing the space food for the International Space Station for European astronauts, Lufthansa Sky Services, that has really this participation of being involved in a space mission or produce something that could be used in space has really been a huge motivational factor for the workforce, but also for the customers, and really enabled some of these organizations to create innovative new projects that may find new markets for them to sell their products. And this is something that we as a company, as Design Data, are now very much focused on, to enable this kind of collaboration between non-space entities and space entities because of our long experience as an organization in this field. Just to give you a bit of background, so Design Data, we are a science communication company with a strong focus on space because of my background. I started off in that industry, And we have been facilitating collaboration, but also been very much focused on communication projects in various forms for science and for space to help communicate projects. Yes. So next, I think it's you, Neil.
Yeah. So last slide of the presentation. So if you think we triggered your innovative thinking, you are also able to make your own space food or astronaut food at home, at least something that looks quite similar. And if you ever wanted to eat out of plastic bags, astronaut food is a chance to do it. Yeah, you can get some of the original recipes from the astronaut's cookbook. It's written by one of NASA's chiefs, and it's full of stories and recipes. It also explains a little bit on how to make food preservation for space flight. Yeah, and what you need is just some tubes, some pouch bags, and vacuum packaging, and then you can be creative and start cooking and enjoy your own astronaut dinner at home. Yeah, thank you for watching.
Brilliant. Thank you very much, Sebastian and Neil, for that inspiring and engaging presentation. We've got quite a few questions that have come up, but we've only got a couple of minutes. So let's try and get in as many as we can before the end. So first question that we had to one of you gentlemen: do food spoilage microorganisms grow in a spacecraft in the same way as on Earth?
The way they can spoil food also depends on how do they get supplied by nutrition, so their need for life, and their gravity plays a bigger role. So for example, if you have no water flow or airflow, they more or less would suffocate at their own location without any supply. So at some parts they can die faster. On the other hand, if they build some kind of structures like a fungus, they can grow quite big without gravity. Yeah.
Interesting. So we have another question here. What are the facilities for baking and cooking already on the ISS?
With the space shuttle, they had an oven with them to heat up food, like something like canned food or so, but the temperature the thing could reach was not high enough for baking. So you would get this white, tasteless thing I showed in the back, and that was it. Otherwise, if they have hydrated food, then they just add warm water. And as long as I know, there is no microwave oven on the space station because it would influence scientific work.
Understood. So we have a follow-up question here. Do you have plans to continue working on this project or a similar like project?
Something?
So Bake in Space itself, we have no plans to continue that at this moment. It has partly to do with the realization that there was really a lack of funding, especially from the food industry, where we thought that we might find more partners that would have an interest, but it really had also a lot to do with the high cost of getting something, getting this hardware done in Europe in that sense. Apart from that, I mean, we're both Neil and myself, we're constantly exchanging ideas on other projects where we are thinking about how to let people participate in exploration and outer space exploration. But food, yes, I mean, it's still a fascinating topic. So, I mean, if I don't know, if there are the right partners, who knows? I mean, we could always talk about potential for taking up the project or picking up what the learnings from what we did in the first round.